The effect of magnetic fields on conductors carrying a current is measured by Laplace's law. There is no physical explanation for this phenomenon. A mathematical formula in no way constitutes a physical explanation. Solid mechanics easily explains the forces mutually exerted by bodies linked, in one way or another, by the principle of equality of action and reaction. But it gives no explanation for the motions of these bodies. Fluid mechanics is the only source of physical explanation of the forces exerted on bodies and the resulting motions. The lift of wing profiles is based on their asymmetry. The Magnus effect applies to all symmetrical bodies such as cylinders and spheres rotating on themselves. The rotation causes an asymmetry of the fluid flow around the body, which explains the Magnus effect in the same way as lift for asymmetric profiles. These phenomena result from the pressure difference around the profile or the body rotating on itself. When tennis, golf or football balls are set rotating on themselves around a vertical axis when they are thrown, they are deflected to the left or to the right depending on their direction of rotation. This phenomenon only occurs in fluids and involves both translational speed and rotational speed. Electrons have angular momentum, a rotation around their axis. An electron moving in a fluid will therefore be subject to a Magnus effect. Air molecules are much larger than electrons. Air is therefore not a fluid for electrons. Since ancient times, ether has been linked to the rotation of the stars and therefore to gravitation. This type of ether today explains gravitation by condensation in the particles, which make up the nuclei of atoms. The condensation flow of this gravitational ether acts on the nucleus of atoms, but the electrons are much smaller than the nuclei of atoms. It can be thought that this ether does not constitute a fluid for electrons either. Several of my videos show that this ether of gravitation cannot be the support for electromagnetic phenomena. However, this position does not exclude the existence of an underlying magnetic ether of some sort. It would be made up of particles much smaller than the particles of gravitational ether. This magnetic ether could cause a Magnus effect on the electrons. A magnetic field exerts a force on a conductor carrying a current. The intrinsic magnetic field and therefore the angular momentum of the electrons traveling through this conductor are oriented in its axis. The cathode ray tube experiment presented in my videos is intended to demonstrate this phenomenon. The electrons are therefore rotating on themselves in the magnetic ether. If we accept that a magnetic field corresponds to a flow of the magnetic ether, the rotation on themselves of the electrons in this flow causes a Magnus force perpendicular to the conductor and to the flow of the magnetic ether. It is the Laplace force which is also the cause of the deflection of electrons by a magnetic field in cathode ray tubes. In this case, this force is called the Lorentz force. Two parallel electrical wires carrying currents in opposite directions repel each other. One wire is in the magnetic field of the other. This magnetic ether rotates around the other wire in a sort of whirlwind. A Magnus effect therefore occurs on the electrons of the first wire and the corresponding force is directed in the direction opposite to the other wire and conversely. The field of the first wire causes a Magnus effect on the electrons of the other wire. The two wires repel each other. A magnetic field considered as a flow of the magnetic ether causes drag on the electrons of a conductor. The electrons concentrate on one side of the conductor. A transverse electric field is therefore produced in the conductor. This electric field orients the intrinsic magnetic moments of the electrons in the direction of this electric field. This is precisely what the cathode ray tube experiment is intended to show. The intrinsic magnetic moment of the electrons is oriented in its direction by the electric field in the cathode of a cathode ray tube, before their ejection under the effect of the anode voltage. But if the magnetic field varies, then the electrons oscillate transversely in the conductor. It is exactly the same situation as for the two parallel conductors. Their speeds are parallel and in the same direction. The electrons therefore attract each other by the Magnus effect, as in parallel conductors, and then repel each other by the electrostatic effect, when the magnetic field is cancelled. An alternating current of the same frequency as the magnetic field is therefore produced in the conductor. In the same way, the motion of the conductor of a circuit in the magnetic ether generates a drag on the electrons parallel to the speed of motion of the conductor. Additionally, the electrons are moving with the conductor. The electrons will attract each other exactly as in the previous case. The same goes for the magnetic field that appears in capacitors when they are charged.